23, the generation time for bacteria is the time that it takes for the population to double. Generation time G can be found using the experimental data in the formula. T is the time period, B is the number of bacteria at the beginning of the experiment, F is the number of bacteria at the end. The generation time for Mycobacterium tuberculosis is 16 hours. How long will it take for 2 of these bacteria to multiply to 256? B in this problem is bacteria at the beginning, which it shows is 2. 16 is G, the generation time. F is the number of bacteria at the end, which it says is 256. So we write down the formula, put in the numbers that we just identified in the appropriate spots. To solve for T, we want to multiply both sides by the denominator. When you multiply 16 times 3.3, you get 52.8. Also, we could change the 256, the argument, to a base of 2 and an exponent of 16. Notice, once again, 16 times 3.3 was 52.8, and 2 to the 16th is coming from the 256. So we continue. What you see here in parentheses, using the log identity number 1, that reduces to just 16. So you have 52.8 times 16. That is the time, and it's being measured in hours, because it says generation time is 16 hours. When you multiply that, you get 422.4. That can be changed. 422 hours is difficult to comprehend. If you want to change that to days, divide that by 24 hours in a day. It gives you 17.6 days, which is much better than just leaving it in 422 hours. We can do better though. Let's leave the 17 whole days. Let's take the 0.6 days and convert that to hours. To do so, we multiply it by 60. Multiply it by 24 hours in a day. That gets you 17 days, 14.4 hours, which is much better than the previous answer. But the 0.4 hours bothers me a bit. Let's leave the 17 days. Let's leave the 14 hours. Let's change the 0.4 hours to minutes. To do so, multiply it by 60. Gives you 24 minutes. Not rounded whatsoever. So the generation time, the time period for it to double. 17 days, 14 hours, 24 minutes. 24, salmon swim 2,000 miles upstream to spawn each year. Scientists have this formula. Oxygen consumption is O, given by this formula. V is the velocity in feet per second. Question A, what is the oxygen consumption of the fish that are not moving? Fish is not moving means its velocity is 0 feet per second. So you write down this formula. Note this O is at the beginning. It's not a 0. It's in the letter O. If you plug 0 in for V, your exponent then becomes 0. 3 to the 0 is 1. So you get 100 times 1. You're getting 100 units. However, oxygen consumption is measured. We don't know, so I'm just going to say it's 100 units. Part B of this problem. How fast are the fish swimming if the oxygen consumption is 2,700 units? We fill 2,700 in for O, and we want to solve the equation. If you divide both sides by 100, you get 27 equals 3 to the 3v divided by 5. If you change this to logarithmic form, you get log base 3 of 27 equals 3v divided by 5. The 27, which is the argument, you could rewrite that as 3 to the third. That enables you to use the log identity number 1 to make that just 3 on the left side. We no longer have any exponents or logarithms, so to solve this equation, multiply both sides by 5. then divide by 3, and you'll find that the fish are swimming 5 feet per second.